Are you a real fan of wind power? Well, after watching this little video, you'll have all the information that you need to know the answer to that question. So these aren't really actually fans. It's called a turbine. They are a rotary engine. That means they are things that spin around, and if you apply some pressure to it, it's going to cause it to spin, and that's how it's going to work to generate some electricity. Inside, what you have is the blades will spin and turn the main shaft. It goes to a gearbox, which is going to use gears to amplify the spin, which then spins the generator, which has a magnet and a coil of wire, and that's going to get those electrons moving and therefore generate our electricity. So wind power obviously comes from wind, but where does wind come from? Well, let's consider what happens at the beach. So you go to the beach and the sun comes up and it's sunny out, and we know that that means there's sunlight coming down, shining on everything. But we've got water and land, and we know that water and land are two different substances and they don't heat the same way. So water is going to warm up slowly, therefore the air above it's going to be a lot cooler. Land warms up a lot quicker, so therefore it's going to have a higher temperature in the air above it. So if the temperature is going to have a difference, that causes a difference in air pressure, and that causes high pressure to push to low pressure, and we call that wind. And so right here you see our sea breeze coming in off of the ocean. And this is the concept of what happens all around the planet. If you have differences in heating, it leads to differences in air pressure, and that leads to wind. So in terms of energy transformations, well, we're starting at radiation energy from the sun, and that radiation turns into heat as it heats the ground, heats the air above it. When the air heats up, it's moving around due to convection, and so it's convecting around, and that is our wind. The wind is going to hit against the turbine blades, and that's going to cause them to spin due to the rotary engine portion of the turbine. And that then in turn is going to cause the magnet to spin around in the coil of wires, and that causes electrons to move, and we have electricity. So if you look at the amount of power that you get out of a wind turbine, it has changed over time. Back in the early 1980s, wind power was relatively small, and as you can see on the diagram, the turbines were pretty small as well. And over time, we've tried making them in different ways, growing them larger and taller, and the net effect has been ones that produce more power. And as you can see, typical turbines produced in the year 2011 are generating way more electricity than they were 30 years ago. A typical wind turbine can generate 7,500 kilowatts of electricity. Now, that would be equivalent to what it would take to power about 2,000 homes in Connecticut. But one turbine by itself is obviously not going to be enough to equal a regular power plant. You need many of them, and so these large collections of wind turbines like you see here, those are going to be known as wind farms. You would need over 600 of these 126 meter high wind turbines, assuming that they work at about 25% of the time, to equal the output of just one nuclear power plant. That's a pretty big difference. But comparing that to solar energy, it could possibly be equivalence of about one windmill to about 16,000 solar panels. So in that comparison, wind looks a little bit better. The other thing, well, remember, while solar panels take up a lot of space, wind farms don't have to take up as much space in the sense that they can be combined with other activities. So when you consider a farmer who has a big plot of land and decides to lease some of that land to a power company, they can install wind turbines. The cows aren't going to really care that the wind turbines are there, and we can get a mutual benefit between these two people. If you look historically at wind power, we showed that the turbines are doing a lot better at generating electricity, but you'll also see growth in terms of its prevalence. So looking at this map, you can see, okay, so some states have it, and you can see some quantities. Overall, 6,740 megawatts of electricity produced in terms of production capacity in 2004. Now, if you jump ahead 9 years, this is what we see. In 2013, you can notice a lot more of that map filled in, and notice those numbers are a lot larger. 61,000 megawatts of capacity. So it's pretty much a 10 times jump in 9 years. That's pretty significant growth. Now, you might have noticed Connecticut did not have a lot going on that map, and part of the reason is, if you look at the landscape of Connecticut, it is not that suitable for wind power. You'll notice that the white color, according to the wind power classification scale, is poor, and therefore most of Connecticut is poor for wind power. But you do notice some trends. You could see that there are parts of Connecticut that show the brown color, mainly in the northwest sections. And then you also notice some of the other colors, like the yellows, the pinks, and the purples, and even a little bit of red showing up in the map all over Long Island Sound. And so that's showing that we have better wind potential in those locations. So that kind of leads us to a really important idea that not everywhere is equally good for wind power. If you look at who is good for it, it would be coastal regions, and even offshore can be even better, flat open regions and hilltops. And with those settings, all three of those places have in common that they have reduced resistance to wind, so wind can tend to be faster and more consistent. In addition, with the coastal region, you have the differences in heating between the water and the land, and that helps to drive pressure differences even more. But even those places that have really good wind potential, they're going to have fluctuations in speed, and that means fluctuations in power. So if your energy source isn't that reliable, it makes it more of a challenge to use. And so what we find is using this as your only power source becomes rather difficult, because you need a way to store energy for those times when it's not windy out. So how are you going to produce energy then? Well, one strategy that can possibly be used is something called compressed air storage. So the way that this works is, let's say it's off-peak, but it happens to be really windy out. So there's not that much demand for electricity, but the wind is going pretty good, so they're able to generate a lot of power, but you just don't need it at that time. You could take it and use that electricity to run a compressor, and that compressor would compress air together, and you would pump it underground. And so this would be hinged upon the fact that you'd have like a cavern or something underneath, so that you could compress air into that cavern. And then let's say you have peak hours and the demand for electricity is much greater. Then at that time you could tap into those the stored energy in the compressed air, and as it comes out, it would spin around a turbine, and that turns a generator, and before you know it, you got electricity. So it's possible to build and engineer solutions to the inconsistency of wind, but the more typical way is to pair a energy source like wind power with something that's more reliable, like coal or natural gas, and that way you can just switch between them when you need it. Now, in terms of problems with wind, one of the problems that sometimes gets mentioned is bird deaths. And so if you look at a particular, this is one of the larger wind farms in California, and you can see, yeah, there are definitely deaths that are associated with these wind turbines, birds flying into them and getting killed. But on the other hand, you might think about this. What's the impact of the alternative? So keep that in mind. So when we look at bird fatalities in a statistical way, you notice that yes, wind turbines can cause deaths, but statistically, it's a lot less than buildings and windows and cats. So after all, yes, we can say there is a potential harm there, but at the same time, we're not saying, well, let's not build buildings anymore because they're killing birds. So it is something that you definitely have to think about and look at all of the evidence when considering the impact of bird fatalities on your decision to build or not build a wind turbine. But bats are something that actually is a little bit more of a concern when you look at what happens with them. Their studies have shown that there's something called barotrauma, which is a big pressure change that takes place very close to the wind turbine. So it's not that the bats are flying into the wind turbines, but they're flying close enough that they experience this very strong pressure change, and their lungs are not capable of withstanding that, and that can cause it to burst, and then they die as a result. So there have been some very significant connections between bat deaths and wind turbines. And Batman's not too happy about that. All right, so one of the other complaints that people have about wind turbines is that they are noisy. If you look at the scale of decibels, how loud things are, you can see that obviously if you're very close, you're going to be able to hear some sounds. But if you get out to a distance of about 300 meters, you're down to a relatively mild sound. It equates it to something like the sound of your refrigerator. I don't know that that would be intolerable. At the same time, perhaps if you had that going on all the time, it would be bothersome. The other things, people think about, well, hey, this is in my backyard. I get to look at this thing. It's ruining the scenery. It's something that sometimes people don't like. However, when you frame it like this cartoon does, maybe it doesn't seem so bad. So in the end, we have definite pros, definite cons for wind power. As far as some of the pros that we didn't talk about too much, got to consider the lack of pollutants, the fact that you're not sending anything into the atmosphere. It is free, it is renewable, and therefore sustainable. So those are some of the things that you want to consider. At the same time, not every place is good for wind, and it does have some potential detractions with the fact that it's inconsistent. It doesn't always work in every setting. So consider those as you are evaluating your different energy sources, and that does it for this one.